I'm at CES 2024 and I'm on the hunt for products using ARM. Well, it's not that hard actually. So much runs on ARM these days, from tiny IoT devices up to massive cloud servers running AI models. I interviewed experts from the automotive industry to an edge AI chip manufacturer, all the way to a company that makes flexible solar cells for headphones that you don't need to plug in to charge. I'm going through all that and more in this video. And thanks to ARM for sponsoring this video. This is the first time I've ever done a full sponsored video. I really want to make that clear since you deserve 100% transparency. Sponsored or not, CES has a ton of great tech, and I got to dive into the things behind the scenes. For all the fancy TVs, self-driving cars, and even pinball machines, if you look under the cover, chances are you'll find ARM. So let's jump right in and talk automotive.
Cars were everywhere on the show floors, from this McMurtry hill climb car to a fully autonomous race car to this flying car and even a tank. Every vehicle on the road today runs on software. And immediately, when I was passing by the automotive grade Linux booth, my Raspberry Pi detector went off. These demos aren't as cutting edge as the flexible solar panels that keep headphones charged forever, but it's cool to see how the same code on their Pi demo units runs on real vehicles. ARM was everywhere. I even found this Pi 400 tucked behind a sign. And I always love seeing companies like Igalia supporting open source projects like they do with Chromium and Vulkan. That's one end of the spectrum. On the other end, Greenhill Software has been building automotive software for over 40 years, longer than I've been alive. They've been involved in the evolution of the software-defined vehicle. But what does that term even mean?
So I'm Joe Faber. I'm the Global Technology Director for Greenhill Software.
One of the things that I think is interesting is like you have a different perspective on software-defined vehicles. How has that evolved out of whatever it was before, which was a lot more hardware, and now it's consolidated and there's a lot more software?
Well, I think software-defined vehicles, at least what it means to me, is the ability to add features after the vehicle's been comes off the production line. Mm-hmm. So your vehicle can grow and you can have new exciting features. For the OEMs, I think it's important because they often are trying to monetize those features, but it's also bringing a lot of convenience for the consumers. A lot of people love the fact that their car can get an update and have some new feature on it. So.
Yeah, I know for me and a lot of people who watch my channel, we're all about the security side too, and we're a little nervous when your car can get an upgrade over the air.
Yeah.
So how do you guys make sure that the updates are rock solid and reliable and all that?
That's a pretty deep question, actually. There's a lot of moving parts to that question.
Yeah.
But Greenhills has been focused on safety and security since we really introduced our Integrity real-time operating system in the mid-90s. It was sort of the driving goal of Integrity was to address those challenges with embedded software. Mm-hmm. And so what it comes down to is having an operating system that can safely separate critical functionality from non-critical functionality. We have Integrity Multivisor. It's in lots of OEMs today, deployed on the road, hosting Android virtual machines like you see in the demo behind you. Mm-hmm. And that Android can be connected to an app store, can take updates, and all that stuff is isolated and protected by Integrity underneath, keeping access to the CAN bus, the vehicle networks, safe and secure.
Yeah. What does ARM give you in terms of why do so many people seem to use ARM processors?
I think it's largely the performance per watt that ARM is able to deliver, and the scalability. So ARM offers from Cortex M0 cores all the way up to Cortex A76 AE, and I'm sure beyond. Maybe we can't talk about those yet.
Even the server grade cores do Neoverse and all that.
Yes, exactly. And that's an area where I think ARM and Greenhills complement each other well, because Greenhills offers compilers, debuggers, hypervisors, including for things like the Cortex R52. That's an R-class processor that added virtualization extensions. We're seeing that in a lot of zone controllers like this S32Z from NXP, and there's an SR6 over there from ST, and we've built a hypervisor. So it's that scalability, and again, Greenhills and ARM, all the way up the product line, we have complementary technologies to address functional safety and security. Things have changed and evolved quite a bit in the automotive space. One of the changes is that traditionally the ECUs were, the hardware and the software was fully developed by a tier 1 supplier and then handed to an OEM, and they put all the pieces together and built the car. A lot of the OEMs want to own more of that software experience and software-defined vehicle and be able to update it over time. And so there's been a shift in where is that software happening. That's been an interesting thing that we've been dealing with, and as a result we have a lot more direct relationships with OEMs these days than we used to.
Another company that's had a deep relationship with car manufacturers is Amazon. I dug deeper into the idea of software-defined vehicles with Amazon's head of automotive, Stefano Marzani.
Traditionally, automotive worked for many, many years, like in electronic architecture of the vehicles of themselves. They have a lot of ECUs, electronic control unit, with a lot of different processors, different operating system, and the development was really starting with having one of these boxes to develop for, right?
Yeah.
So, and but that, do you think that enables the community of developers, big one, to develop software? No, it doesn't. So consolidating, that is happening right now in the sector, luckily, and we are very happy about it.
I keep hearing this word SOAFEE or SOAFEE, or how do you say,
Yes.
How do you say that, and what does that mean?
SOAFEE, yeah. It's SOAFEE, Service-Oriented Architecture for Embedded Edge. And it's an initiative ARM and other, including AWS, launched a couple of years ago. Because really, how do you achieve software-defined vehicles?
Yep.
You need to define some really basic elements, right? And the main objective for SOAFEE was to challenge a problem that we call environmental parity. What does that mean? It means you develop software wherever, it will just work wherever. So just respecting the instruction set architecture. And that's why we collaborated with ARM a lot in the past couple of years.
Stefano took me on a tour of a modern developer workflow, showing me how devs can program virtual dashboards on their workstations and in the cloud, and then deploy that code to real hardware. I even spotted one of those AdLink developer workstations, like the 128-core Beast I'm testing here. But the key is being able to abstract the hardware in a modern vehicle.
So before, you need to have the hardware, and how many hardware you can have in hardware in the loop. 100, 500, but you can't have millions. Mm-hmm. We can absolutely have tens of thousands of virtual ECUs running in cloud and perform all kind of weird stuff in there. Fault injections, permutation of conditions, attacks, right? Because it's just a virtual ECU, but it's a realistic one. In fact, if you look at the demo, each of these virtual ECUs is assigned a VIN, like a real card. So there's an extreme level of fidelity that you can leverage to boost security studies. So that's pretty exciting front. Mm-hmm. So if your target is ARM on the car, you need to use an ARM processor in the cloud, because it's the same instruction set.
I dug into Amazon's Graviton processors a little deeper. I really wanted to know, why did Amazon build their own silicon for their data centers?
Our data centers are big, and they consume a lot of energy. It was very important, since we have several objectives on sustainability, to reduce the energy amount, and the ARM architecture is fantastic for that. So it really helped us to reduce significantly the amount of energy that is used in the data centers. And it's an efficient instruction set.
So ARM silicon can perform and it's efficient, but you really need a solid OS for your car too. One great option is Ubuntu Core, and I asked JC from Canonical about it.
So I'm JC, short for Jean-Charles. I'm from France, and I work with Canonical as the head of the field engineering team for EMEA. Ubuntu Core is a product that has been designed and engineered by Canonical 8 years ago, back in 2016. And it was out of the phone project that has been abandoned. And we took back from this a few technologies that we thought made sense in the world of embedded systems. One of them was making an immutable system. So it's a read-only system, fully secure, that you can only update through OTA with a signed system and packages. So we use the Snap package that have been designed for the phone, and that has been now deployed in the desktop and every kind of environment. But we went further, and the snaps are strictly confined in Ubuntu Core, which means that unlike on the desktop where you can do everything except what you prevent the system to do, on Ubuntu Core you cannot do anything. You have to open up connection, you have to allow the snap to access the network, to access the screen. You have to allow snaps to communicate with each other, which makes it even more secure.
I spotted another Ampere dev kit board stashed in their booth, but I wanted to ask, how does Canonical certify their software on so many different ARM boards, even including the Raspberry Pi?
I saw on the website that there are certified systems, like it will work with this. How does that work? Do you have like a testing lab? Do you work with the vendors directly? How do you get those things certified?
The approach of Canonical is to to provide a solution to the entire food chain, if I may say. So we have customers coming to us with their hardware already designed, their solution already packaged, and then we will help them to have to get the best out of Ubuntu. So we will optimize the kernel for their platform. We will integrate whatever drivers they need. This is what we call enablement. Mm-hmm. And we also discuss with ODM. And ODM, as you know, is a design platform based on the CPU, and we work with them to have a pre-certified Ubuntu available, Ubuntu and Ubuntu Core. Yep. Most of them available on the platform, so that people who are not yet decided on using a platform, they can just pick up a random ODM and get something out for them.
I also spotted this Pi running one of the demos and asked how Canonical sees Pi in their IoT efforts.
The beauty of Raspberry Pi is that, well, it changed the way people are thinking about embedded systems and are thinking about home appliances and a lot of things. There have been so many very surprising things done because of the Raspberry Pi.
It's a great platform to hack on and to bring you up into the ecosystem.
Yeah.
But ARM wasn't just in cars. All over the floor, I spotted ARM-powered devices. It makes sense. I mean, 70% of the world's population uses products powered by ARM. And at CES, I spotted devices like the OneCourt that uses a Raspberry Pi and 5G to deliver real-time Braille updates to make it so people who can't see can watch a football game. I also spotted an ARM processor on this smart radar drone that lets it process radar data in real time. And everywhere you looked, people were slapping AI in front of the word to make it sound impressive. But one company that was doing real AI work was Himax, and they partnered up with Seed Studio to build a powerful second-gen Grove Vision module powered by their Himax WiseEye 2 AI processor.
We actually have two different generations. The second gen we use ARM, so we have 3 cores. So one that's M55 running on the 150 megahertz, one is 400 megahertz. The other one we have dedicated NPU. So that's called U55. So that's beautiful of our architecture. So we can really run in very low computing power with a 150 megahertz one, and we use the AI whenever we need.
Mm-hmm. Okay, so you can save power and turn off one of the cores if you don't need all that. Another feature that was interesting, I saw the physical unclonable security functionality. Mm-hmm. How does that work? Because it is important if we're using these for security purposes and things that you don't want people tampering with the chips.
Yeah.
How does that work? What's the importance there?
Exactly. So especially for AI, the IoT, the security will be primary consideration for the chip. So we have like a PUF, like an IP, security IP, that's typically just like a security engine built into our chip. So you can consider there's a fingerprint in the chip.
And what kind of battery life could you expect? Could you run it off of solar power, those kind of things?
Well, yeah, that's because a Himax WiseEye solution, we really focus on AI, very powerful AI running on the very ultra low power scenario. So most of our consideration will be AI and low power. So like the thing right here, the skeleton, this is running like a full-time AI, only like a double-digit milliwatt. So less than 100 milliwatt. So normally our average time, like this, we have this guy right here, PIR security camera. This have 3 years lifespan by using our sensor and our AI processor. So typically like around like 2.6 milliwatt. Power consumption in average, that will be the goal. We're looking for like, we kind of greedy. We want to try to reduce down to like 2 milliwatt. Mm-hmm. So we're working on that.
So you could have this up, put it up for 3 years. You don't have to go out there on a ladder every day.
Yeah.
And
battery driven, not solar.
Himax's AI tech can run for years on just a battery. But what if you could run it practically forever without ever changing the battery? That may sound like magic, but that's exactly what Exeter is doing with Powerfoyle, putting this tech in wireless headphones and headsets, remote controls, and even IoT buttons that always stay topped up from light energy. But how? Well, ARM's efficiency is one of the big reasons this is possible today.
How does that work with solar? Like, you still have to plug it in, right?
No, I would say for most users, you don't actually have to plug it in. There are going to be some extreme edge cases where maybe, yes, but it really becomes a duty cycle issue. If you use them outside, for instance, you gain more power than you consume. But even if you use them in low light conditions, if you store them in the window or you have them around your neck when you're commuting to work, there's enough light to power them. And so I would say most users, no, they don't have to charge them.
And another problem that I think of is like solar panels on roofs, they're kind of fragile, glass and all that. Like, how did you make it so that you can have a solar cell in a headphone or in some consumer product where people are just throwing them around, putting them in their bags, maybe stepping on them?
No, but you're right. I mean, solar cells as a technology has been around for a long time. What we did, and that has been to develop a flexible solar cell that's also very durable. So it can take, a fair amount of mechanical beating and temperature variations, UV exposure. So you really make a durable product. And we're not trying to compete with, silicon solar cells for power generation. Yeah. This is really for product integration, to replace batteries and charging on products.
The other part that I think of, like, solar is great and you can get some energy, and the solar efficiency is getting better and better, and you guys seem to have done a good job, but there's the whole back end of how do you use that power effectively. Yep. And that's where I think ARM comes in.
Yes.
Can you explain why do a lot of the devices that do this use ARM?
Yeah, no, I think you're entirely right. I mean, so we have a fantastic solar cell, but there are limitations, right? I mean, we can only generate so much energy, and to make a good product, that energy has to be used efficiently. Mm-hmm. And that starts with processing and communication. So we only make the solar cell, but we try to partner with companies and build reference designs and solutions to make energy efficient products. And then it becomes quite natural to work with ARM, because ARM has maybe or probably the best power efficiency in semiconductors.
I know as a programmer, I'm jealous. I'm always guilty of putting in things where it's like, I can do that, and you end up like you have a loop that's just consuming energy.
Yes, and yeah, the hardware is one thing, but you're absolutely right. I mean, energy efficient coding to make sure that you go down into deep sleep as soon as you can, and for a tracking device, for instance, how often do you wake up to send data? Do you wake up on a time interval, or do you wake up on a low power, accelerometer or something? Yeah. Right? So yes, you should think of power efficiency on a systems level to build great products. Yeah. And I think that's one of the great things with these dev kits is it's a low threshold to start working on that.
It's awesome to see how many new use cases are uncovered just by cramming more performance into smaller and smaller power envelopes. A pinball machine plugged into the wall running on ARM cores doesn't really need that same efficiency, but a wireless AI security camera that only needs a battery change every few years? ARM's all over that. And I wanted to find out more about where ARM's headed, so I got to speak to Chris Berge, the SVP of ARM's client line of business. When I started out working in small electronics and things, it seemed like ARM was small, low-end, small devices, TV boxes and phones and things, but nowadays I see it in servers, automotive, everywhere, every kind of device. Where is ARM the best?
Well, so, a lot of our legacy, it does come from energy efficiency, right? And, some of our earliest company-defining designs were early Nokia phones or Nintendo Game Boys and these kind of mobile devices. So really efficient RISC design is fundamental to the company. However, we've seen those types of products and what kind of a smartphone can do today and the types of performance that is required. Power is becoming a challenge in all kinds of applications. And in fact, even you take a data center, right? Which you think about a data center, why do they care about power? Well, actually one of the biggest challenges, especially as we get to cloud scale data centers, is how much power can they deliver and get to that data center, that huge warehouse style data center, 500 megawatt type data centers. Of course, power is super expensive, and we all want to be, good consumers of power. And so, once you have that 500 megawatt data center, how much compute can you get in there? So it ends up being we want really efficient computing, and you can see that with many of our Neoverse customers that have taken our ARM processors to data centers. Great example, and I know you do a lot with Ampere, being able to scale that out to 128, 256 cores. That's more jobs that can be servicing, providing services to people, providing computing services. So we see it in data center, in automotive, right? We have a nice picture of a car here. I'm not sure if it's in frame, but in automotive, electric vehicles and the amount of computing, and especially as we talk about all the AI and all the autonomy. So really efficient compute is just a fundamental requirement in today's devices. And then, we can go from those big computing devices we talked about to super small products.
Now, obviously ARM is bragging a bit, but it's not a lie. Having an architecture scale from the tiniest devices to massive servers is no small feat, and that makes the ARM ecosystem easy to tap into.
We have 15 million developers at this point in time developing on ARM relative to applications. I think many of them are your users, your listeners, whether they're using Raspberry Pi or other types of products. So it's both the technology scale that we're able to provide with these high volume markets, and take that architecture and scale it up and down. Yep. And then on the software side, the huge scalability you get from RTOSes to Linux to all kinds of application development.
Like, what does ARM give to continue advancing the industry in terms of performance and efficiency and everything?
So it's a great question, Jeff. So yes, lots of discussion, is Moore's Law dead or whatever. We are absolutely continuing to push the envelope on technology, but we're absolutely having to be a little bit more thoughtful, not just counting on lithography or the fab to just make things better for us. So there's a lot of work that's being done now around looking at those next generation technologies and figuring out, okay, what types of decisions you might want to make, what type of caching decisions you might want to make, what kind of scale decisions you might want to make, and how do you want to deal with that.
We also discussed chiplets and mixing multiple types of cores, and Chris highlighted how ARM pioneered the big-little architecture behind some of the most efficient and flexible processors today. ARM was running behind the scenes all over the place at CES, and I'd like to thank them for sponsoring this video, and for sending me to Vegas for my first CES experience. Until next time, I'm Jeff Geerling.